Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's average level difficulty puzzle, and it's called Dutch Flatmates. Kropki Doots, or it's actually Kroopki Doots. It's not even Kropki, it's Kroopki Doots by Damo89. And here are the rules. Normal Sudoku rules apply, which means place the digits 1 to 9 once each in every row, column, and 3x3 box. Dutch flats. Every 5 in the grid must have a 1 directly above it or a 9 directly below it. It may have both, but it doesn't need both. So for example, if this was a 5, it needs to have a 1 or a 9, a 1 above it or a 9 below it, and it can have both, but it has to have at least one, but doesn't have to have both. Kropki dots. Digits on a white dot are consecutive. Digits on a black dot are in a 1 to 2 ratio. I guess it should say white dots separate digits that are consecutive, and black dots separate digits that are in a 1 to 2 ratio. So, for example, if this was a 6, this would have to be a 5 or a 7. If this were 2, this would have to be a 1 or a 4 to maintain a 1 to 2 ratio. Kroopki doots. Doots are straight lines between sets of cells. A white doot separates two sets of cells whose respective sums are consecutive. So, for example, these 3 digits must sum to a value that must be 1 greater or 1 less than these 3 digits sum to, right? Because it has to be, the sums have to be consecutive. A black doot separates two sets of cells whose respective sums are in a 1 to 2 ratio. For example, row 1, column 1, and row 1, column 2 is double or half of row 2, column 1, and row 2, column 2 because of the black doot between them. Not all dots or doots are necessarily given. So there could be, yeah. I think, yeah. I don't know if that needs clarification usually. I think, yeah. I don't know if I think the format should always be basically you can I think you can specify them differently, right? So you could say like for dots, white dots separate digits which are digits which are consecutive. So white dots separate cells that are consecutive. If you wanted to basically say that there was a negative constraint, what could you do? You could have something along the lines of every cell that is consecutive must have a white dot between them. Yeah, I don't know. Maybe that's too. Maybe I don't know. I haven't thought it through, but maybe that's too like, you know, I don't know. It doesn't. Maybe it doesn't make sense in a certain way. I don't know. Anyways, those are all the rules, and if you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, so we know these are in a 1 to 2 ratio. These are in a 1 to 2 ratio. And so this has to be 1, 2, 3, 4, 6, and 8. So 1, 2, 3, 4, 6, and 8, right? This can contain 5 or 7. So one of these has to have a 5 or 7 or a 9. And it could be both, I guess. This is a 1 to 2 ratio. This is a 1 to 2 ratio. So therefore, this is times 3. This is times 3, right? One of them is double the other one. So that's 3x. This would be another 3y. And this would be 3z. So they're all multiplied by 3. So 45 is also a multiple of 3. Therefore, this must be a multiple of 3. So it's 3, 6, or 9. So it must be with 2, 4, 5, 7, or 8. Yeah, and so this, again, these two numbers are one is double the other. So one is 1x and the other one's 2x, right? So they must be add up to 3x. The same here, except like it's a different x, right? Or it's a y if you want to put it. So 1y plus 2y is 3y. This is the same thing. This is 1z plus 2z equals 3z. So they're all multiples of 3. 45 is also a multiple of 3. Therefore, if you subtract out a multiple of 3 from a multiple of 3, you'll always have the difference will be also a multiple of 3. So you know this is 3, 6, or 9. Which means 5 and 7 are here. 5 and 7 could be with 2 and 4 only. So 5 and 7 have to be on opposite ends. Because if you have 5 and 7, that adds up to 12. It can't be, the two digits can never add up to 24. So 5 and 7 have to be the top if they were in a 2-to-1 ratio with something. So it would be a 2-to-1 ratio with 6. But the only possibility for 6 then would be 1, 2, and 4. And that would eliminate the possibility of having two doubles here. So 5 and 7 have to be opposite each other. 5 cannot be with any number that is larger. So 5 can't be with like the larger sum because 5 and 9 add up to 14, and 14 is already double of 7. So 5 has to be in the smaller sum. So 5 is with like either 1. So if 5 is with 1, 7 would have to be with 5. So the 5 can't be with 1. Therefore, we know 1 and 2 have to be here, right? Because 7 and 1 doesn't add up to anything that 5 can add up to, doubled or less or halved. So 5 and 1 was the only option to have 1 in this Doot. So 5 and 1 cannot be there. Therefore, 1 and 2 can't. 1 and 2 have to be a set. So 5 and 3. If you have 5 and 3, that's 8, and then you would have 7 and 9. And that, I think, is the only one that works, right? 5 and 3 add up to 8. 7 and 9 add up to 16. If you have 5, you can't have 5 and 4 because that would be 9, and then double that is 18. So yeah, it has to be 5 and 3 and 7 and 9. Which means this has to be 6. So this can't be 2, 4, or 8. This cannot be 3 or 6. So it's 1, 2, and 4, 8, right? All of this is double of something here. So we know this is even, this is odd. One of these has to be even because it's either 2 or 4 or 8. And if they were both even, it would be, well, I guess this could be the top one. Okay, say it was 4 and 8. If it's 4 and 8, this would have to be at least 6 and 5. So this is 12. And this would be 11, so it's 23. So 4 digits would have to add up to 46 because you can't have half of 23. So that's impossible. So this cannot be 4 and 8. So this has to be 1 and 2. So 1 and 2, this is consecutive with something. So it's 13 or 11. So this cannot be 1. So we know 1 has to be one of those 4. This is either 9 plus 5, which is 14. So it'd have to be double that, which is 28. Or this is 9 plus 7, which is 16. And 16 doubled is 32, which is not possible for 4 unique digits, because the max is 6, 7, 8, and 9, which would be 30. You cannot have 32, or not 32. It would be 16. You can't have, if you can have 16, but that would be 8. And you can't have 4 digits that add up to, unique digits that add up to 8, because that minimum is 1, 2, 3, 4, and that would be 10. So it has to be double of 1, 2, 6, and 5, which would be 14. So this would add up to 28. 28 is, you could have 4, 7, 8, 9. So this is either 4, 7, 8, 9, or it's 5, 6, 8, 9. You must have an 8 and 9. Right. So this can't be 5. This can't be 4, 6, or 8. These three are in a 2-to-1 ratio with something which is consecutive, and these all add up to 45. Oh, that's interesting. You could have 24. You can't have 24. 24 doesn't work there because you have 24, 12, and then 11 at the minimum. 24 plus 12 is 36, and then plus 11 is 47. You could have 23, though. If you had 20, but then we know this adds up to 28, so you can't have 23. What about 22? 22, 11, and 12. Does work. So we know this is 28 here. These two are in a 2-to-1 ratio, and this one's consecutive with this. 22, 11, and 12 seems to be only one that works, because 23 cannot be here because this can't be 5. So this would be 28 minus 5 would be 23, but that's not possible because the 5 can't be there. 28 minus 6, however, is 22. 22 plus 11 is 33, plus 12 would be 45. So that works. 24 we showed doesn't work. 24, 12, 11 is the minimum, so it's 47. So therefore, and then if you try to go lower than 22, 21 doesn't work because you have to have 42 here, which doesn't work. And then like if this were 9, this would have to be 19, which would be double, would be 38, which is not possible for 3 digits. Therefore, it's 6. If you continue going down, it just doesn't work, right? So say you try 22, so 22, 11, 12 works. If you try 20, that's 20 and 10, and then consecutive would be 11, so 41 at the max, so that doesn't work. So this has to be 6. It's 22, so then this has to be 5, 8, and 9. Yeah. This is 5, 8, and 9. This is 11. It cannot be 8. Cannot contain a 5. This is 11, and this is 12. So the rest of this is what? 1, 2, 3, 4, and 7. So 7 cannot be here, obviously. The rest of this is 4, 3, 4, 7, 8, 9. Okay. Interesting. So this is 22. This is 11. So 11 could be 1, 3, 7, 1, 4, 6. So this can't be 8. No, 4, 6. That's all the ones. 2 can be 2, 3, 6. And 2, 4, 5 cannot be because 5 is here. So it's 1, 2, 3, 4, 6, 7. This can't be 4, 6. So it's the same here, right? Except it's 2, 4, 6, 2, 3, 7. Yeah. And 1, 4. No, 1, 4, 7. Yeah, it's possible. Okay, so this is 12. This is either 11 or it's 13. If it's 13, it has to be 4 or 9. If it's 11, it could be 2, 9, 3, 8, or 4, 7. So any of those work. This is in a 1 to 2 ratio. Can this be 1, 2, and 3? No, because that would be 6, and then this would have to be at least 12. And 3, 4, and 7 is that minimum 14. These are consecutive. That's interesting. So this is 3x something. This is 3x something, right? Because one of them, it's the same principle here, right? This has to be one of these is 2 times the other. So that means it's 1x plus 2x, which makes 3x. Same here. So this consecutive number, these consecutive numbers must add up to a multiple of 3. So it's consecutive, multiple of 3. We know this is, again, this is what, 14? Yeah, you have 14 plus 28. So that's 42. So these add up to 42. 42. These two. We have 48 left. So this is 48 left, 42. For these, this isn't a 1 to 2 ratio. We can have 1, 2, and 4, and 3, 4, 7 works. So 1, 2, 4 plus 3, 4, 7. But that doesn't really work. If this is 1, 2, 4, and this is 3, 4, 7, we have 8, 9 here. Which means that this has to be 3 and 7. So 3 and 9 would be... Right, okay, so for 1, 2, 4, so that'd be times 7. 7 times 3. But it would have to be 1, 2, 1, 3, 4, right? Sorry, 1, 2, 4. 1, 2, 4, and it would have to be 3, 4, 7 with that. So 14 to 7. So minus 21. So 48 minus 21. But then you have 8 and 9 here. And this would have to be... So, okay, what we're trying out is... This is 1, 2, 4. This is 3, 4, 7, right? This would have to be 8, 9. This would have to be 3 and 7. 3 and 8 forms 11, but 7 and 9 forms 16. 3 and 9 forms 12, but 7 and 8 form 15. So that doesn't work. What about if we tried 1, 3, 4? If this is 1, 3, 4... Also, this has to be an odd number. So since this is even, this has to be odd, which means this has to be even. Is that right? No, because, yeah. This has to be odd. Right, because, yeah, it adds up to 90, not 45. So normally 45, you have an odd number, you have an even number, an odd number, and it has to have an odd number with it to add up to an odd number. But since these add up to 90, which is an even number, we know this is even. We know this has to be odd because of consecutiveness. So therefore, this also must be odd. So 1, 3, 4 does not work. So 8 does not work. What about, let's see, 1, the next step is, so 1, 2, 3 does not work because that's even. 1, 2, 4 doesn't work because it just doesn't work. 1, 3, 4 is even, so that doesn't work. So that's 8. So we tried 8. Can we make a 9? No. Can we make a 10? 10 doesn't matter because it's even. 11 would be next. So 11 would be 137. And I think it would have to be 137. With 22. Oh, so that's what it has to be. It has to be 11 and 22 because this can't get any higher. But it can't be 22. We missed 9. Yeah, so this can't be 22 because there's no 5 and 6 available. 24 would mean this is 12, and therefore this is even, which doesn't add with an odd and an even to form an even number. So this has to be 9. This is 2, 3, and 4, which means this is 1 and 7. This has to be 18. And we have a difference of 6 here, so we need a difference of 5 or of 9 here. So 7 does not have a difference of 5. Sorry, 5 or 7. Difference of 5 or 7. 7 doesn't have a difference of 5 or 7 with 3 or 4, so 7 has to be here. So this must add up to 11, which means it's 3 and 8, right? 3, 7, and 8 add up to 18, which is 2, 3, and 4. So this, if it's 2 or 4, it's 1 and 8. If it's 3, it's 6. So this is 3, 7, 8, which means 4 and 9. So this can't be 9. This can't be 4 either. So this has to be 11 then, because that's the only thing that fits. So it has to be 3, 8. So this is 8, this is 8, this is 3, 7, 8. 2, 3, 4. This can't be 3 or 8. So this can't, okay. This has to be 1, 2, 4, 7, 9. 4, 7, 9. And it cannot be 1 and 7 because we know that's here. So the 7 goes with 4 and the 9 goes with 1. So this has to have a 1 and a 7. We don't know which though. It's already 1 to 2 ratio. This has to be 1, 7, 2, and 6. 1, 2, 6, and 7. This is in a 2 to 1 ratio. If it's 3, it cannot be... Okay, so the minimum is 10. So this is always the double here. So then this has to be even. So it always has to be 3 and 7 then, which makes this 8, which makes this 1 and 4. Therefore, this is 2, 5, 6, and 9. If this is 2, this is at maximum 6, and that can never be. So this can't be 2, because this can't be consecutive then. 2 and 4 would be 6, and that would have to either be 5 or 7, and that's not possible without with 5 and 6 at minimum. Okay. What else do we have? If this is 2, 4, that would mean it's 6, which would mean it's consecutive with 5 or 7. But there's no 5 possible there, and there's no 7 possible because we already used 2 and 4 and 1. So it cannot be 2 and 4, so it has to be 2 with 9 or 4 with 9. So it's either 11 or 13. If it's 2 and 9, that means it has to be with 10. So this is 10, 12, or 14. If it's 10, it would have to be 2 and 8. So 2 and 9 and 2 and 8 would be there, so that doesn't work. So it cannot be 10 and 11. It has to be 11 with 12, if that's the case. So that would be 2 and 9, and this would be 4 and 8 then with it. If it's 4 and 9, that cannot be 12 because 3 and 9, 4 and 8, and 5 and 7 are all taken. If it's 4 and 9, could it be go up to 14? No, right? If you have 4 and 9, can't go down because you already have 3 and 9 is the 9's already accounted for, the 4's accounted for, and the 7's accounted for, which eliminates 3, 9, 4, 8, and 5, 7. So there's no 12 possible there. If you try to go up from 13, so 13 up to 14, you would have to have 4, 9, and then you can't have 5, 9 because the 9's already being used, but you can't have 6, 8 because the 6 is being used. So this has to be 2, 9 here, and this is 4, 8. So this is 1, 4, 7. This becomes 3 and 6. So there's no 6 here. This can't be 4. So this is 9, which means it's with 1. So that becomes 7, 4. So this can't be 1. This has to be 3 and 5 with one of 2 or 7. It can't be 7. I guess it's 2 or 6. No, because 6 is here. So this has to be 6. So this can't be 6. Wait. This is not 3 and 6. I don't know why I had the 6. 3 and 6. 3 and 5. There we go. So, okay, back to this again. This is 3 and 5 with 2 or 6. That works. This is 8 and 9 with 2 or 6. I think it has to be, right? So, let's see what these can be. So that's that. What is this? Say this was 9. It could be with 1, and that would be 5, 6, and that would work. If it's... So 9, 1 works with 5, 6, and then this would be 2. So that works. So if this was 9, this is 5, 6, this is 2. What about if this is 6? If this is 6, it could be 6, 4, and this would be 2, 9. And this would be 5. Can it be 6, 1? That would be 7. And you would not be able to have a 2 with it. Anything that would make it. So no, it cannot be 6 and 1. So it's 9 and 1, or it's 6 and 4 so far. What about 5? 5 and 1 would make 6, so it would have to be next to 5 or 7. But the 7 can't work because you are using the 5. So 2, 5 doesn't work. So 5, 1 doesn't work. 5, 4. If 5, 4 is... so this can't be 1. This can't be 4, so this is 8. So this is 4, which makes this 3. This is 8. These can't be 3. This can't be 7. So one of these is 7. If it's 5 and 4, that's 9. So this would have to be 8 or 10. So it could be 5 and 4. Because then this could be 2, 6, and this would be 9. So that is possible. Those seem to be all the possibilities there. This is either 5. If it's 1, 4, this could be 1, 5. It cannot be 2, 4. If this is 1, 7, there's a lot of possibilities here, I think. If it's 1, 7, that means this has to be 7 or 9. 7 cannot be 1, 6, cannot be 3, 4. Could be 2, 5. And 9 cannot be 1, 8, cannot be 3, 6, cannot be 4, 5, so this is 2, 7. So that's 5 and 8. What about 4, 7? 11 would mean 10 or 12. 10, you can have 1, 9, cannot have 2, 8. You could have 3, 7. You cannot have 4, 6. 12 would have to be 3, 9, or 5, 7. So, yeah, those are... That's all the possibilities. That's a lot of them. This can't be 2, 3, or 4, so this becomes 1, 5, 6, 7, 8, 9. Obviously no 8 here. These are consecutive. Can it be 1, 2? Then this would be 4, 3, 6. It looks like it could be 1, 2. So 3 is here. 3 has to be with 5, so this cannot be 5. So then, sorry, this has to be 5, so this can't be 5. Right, so 3 is with 5. So if 3 is one of these, if 3 is here, 5 has to be here. If 3 is here, 5 has to be here. 7, 9 is one of the two. Huh. This is consecutive with this. This is consecutive with that. That doesn't tell us much. Oh, every 5 in the grid. Huh, that's the I forgot about the Dutch flats. Okay, so if this is a 5, one of these is 5, so therefore the 9 has to be here. So this can't be 9. This cannot be 5, because if it were 5, there's no 1 above it, and there's no 9 possible to be below it. This could be 5 because the 1 is above it. This has to be 1. This can't be 5 because they cannot have a 9 below it and a 9 above it. So therefore this is not 5. Well, we already kind of knew that. If this is a 5, there's no 9 above it, so this has to be the 5. So this is 5, 3, which means there's a 9 below it. That's 3 in the corner. That's a 7. So this is a... Right, so this cannot be 5, and this can't be 9. This can't be 3, and this can't be 7. This 5 has a 9 below it. This 5 now could have a 9 below it. If it's 5, 4, 2, 6, 9, that works. If this is 5, so either this is 5, 4, and this becomes 9. So then this would be 6, 2, which is fine. This can't be 7. So since this can't be 7, this has to be the 7. 5 could be here, which would have the 1 above it. And the 5 would have to be with 6, because I don't think it could be with 2. If it's with 2, 6 and 1, 6 and 4 doesn't work. 9 and 1, 9 and 4 don't work. So 5 cannot be with 2. 5 can't be with 9 either. So 5 would have to be with 6 here, but 2 can be with 6 here also. What about the 5 here? This 5 can never have a 1 above it, so the 5 has to be here with a 9 below it, so that's fine. This can't be 9 anymore. What about this 5? This 5 cannot have a 3 above, 1 above it, so the 9 has to be below it, which means this is 9, which means this can't be 9. So either this is 9 and 1, this is 5 and 6. This 6 and 4 does not work anymore. So this can't be 6 anymore. Therefore, the 6 has to be here, which means the 6 cannot be here. So this is either 2, 6, which is 8, and 5, 4, or it's 5, 6, and this is 9, 1. Let's see. 9 can never be below the 5, so therefore this can't be 5. The 1 can't be the 9 can't be below it, the 1 can't be above it, so this can't be 5. The 5 has to be either here. So if the 5 is here, this is 1. If this is 5, the 1 has to be here. So therefore 1 cannot be any of these. So this can't be 2. This is 3 or 4. So if this is 5, this could be 1. If this is 5, that could be 1. So this can never be 1, right? If this is 5, that becomes 1. If this is 5, so 1 has to be one of these 3. So this can't be 1. Because 1 has to always be above a 5. Or sorry, the 5 has to have a 1 above it or 9 below it. And they can't have a 9 below it, so it must be a 1 above it. We know the 9 is here, so 5 can be any of these 3. 1 can also be any of those, so that's fine. This is 1, 2, 3, 5, 7. Obviously the 5's there. The 9 has to be here. The 8 has to be here. So the 5 has to be here, which means the 1 has to be here. Because there's no 9 here, so this has to be 1. Which means this can't be 1, so this is forced to be 2. This is 1. There's no 1 or 2 here. No 1 or 2 here. So the 9 has to be here, the 5 has to be here. This 5 works fine. This 5 needs a 1 above it, so that's 1. So this becomes 1, 8, and 1 of 3, 4, 6. But you don't know which. Okay. 1 is one of those 3. Okay. So this is either, again, if this is 1, 3, 7, this has to be 9, and this is 5, which satisfies that. So this is 11 again. 1, 3, 7 works. 1, 4, 6 makes this 8 and 8. So this cannot be 1, 4, and 6. So 1, 3, 7 works. So it would have to be 3, 1, 7. 1, 4, 6 does not, because there's a 4, 8, and a 6, 8 there. That would make both of these 8, which is not possible. 2, 3, 6. If you have 2, 3, and 6, this would have to be 9, and therefore this would be 5. But this can no longer be 9, so the 5 would not have a 1 above it or a 9 below it, so that wouldn't work. So this has to be 1, 7, 3. So then this is 3. This must be 2, 4, 6. This can't be 4, 6, so this is 2. We have 4, 6 here. This can't be 3 anymore. This can't be 2. This can't be 2, so this is 9, which makes this 2. This can't be 9, so this is the 9, which means the 5 is above it. So this is 3. This is 8. This is 4. This can't be, this has to be 6 and 8. So no 6 and 8s here. This can't be 9. So it's 1, 7, 1, 5, 7. This has to be 2. Okay, so what can this be then? If this is 1, 4, this has to be 1, 5, right? So 5 and 6. If it's 1, 7, it's either 7 or 9. But it can't be because these are all odds. So it cannot be 1, 7. If it's 4, 7, it would have to be 5, 7 here. So it's 1, 4, this is 1, 5. Or it's 4, 7. So 1, 4 or 4, 7. So this can't be 4 here. Right? 1, 4 means this is 1, 5. 4, 7 means that this is 5, 7. So we have a 1, 5, 7 triplet in row 3. So the 3 can only be here. 3 has to be here. This can't be 3. This can't be 1, so this has to be 7. This is 1. So this has to be 5 and 7. So therefore this is 4 and 7, which means this is 1. So this can't be 1. So there's no 7 anywhere here because there's a 7 in one of these two, there's a 7 in one of those two. So the 7 cannot be here. So the 7 has to be one of those 3. This is 2, 4, 6, and 9. These are consecutive. So this is 1, 2, 3, 4, 5. No 6, no 8 or 9. So this is not 1 or 3. This cannot be 3 and 4. Can it be 1 and 2? If it's 1 and 2, that's 4, 3, and 6. So possibly, yep. So it could be 1 or 2. Cannot be, could be 2 or 3. If it's 2 or 3, this is 4 and this is 1. So that seems okay. So 2 and 3 seems okay. 3 and 4 obviously doesn't work. 4 and 5. If it's 4 and 5, this becomes 3, 6. This is 7. That's 3. So 4 and 5 does not work. 5 and 6. If it's 5 and 6, this becomes 7, 8, 4. So that's 3, 1. Yes, it could be 5 and 6. Oh, this can't be 1. So it could be 5 and 6. Can it be 6 and 7? If it's 6 and 7, actually, maybe we tried 6 and... If it's 5 and 6, this is 7, 8, 4, 3. Yeah, okay, so that's fine. 6 and 7 means this is 8, 4, 5, 3, 1. So 6 and 7 does seem to work. 7 and 8. If it's 7 and 8, this has to be 3, 6, and that would be 3, so it's not possible. 8 and 9. 8 and 9 means this is 3, 6. This is 2. So that seems possible. So this could be 8 or 9. 8 and 9. Okay, this can't be 3. So this can't be 2 then, because 1 and 3 are not allowed here. So this can't be 2. So it's 1 and 3 with 2. 5, 6 works. 6, 7 works. 7, 8 works. And 8, 9 works. This is consecutive. Hmm. Ugh. We know there's a 3 here. Hmm. Every 5 must have a 1 above it. Okay. So 5 has to be one of these two. 1 has to be one of those two. Can this ever be 7? No. If it's 7, this is 1, that's 5, and the 5 does not have a 1 above it or a 7 or a 9 below it. So this cannot be 7. If this is 5, this is 5 and 4, 2, 6, 9. Or this is 5 and 6, and this is 9, 1. If this is 1 and 2, this has to be 9. This is 4, 3, 6, 7, 5, and this would have to be 8. If this is 2 and 3, this becomes 9, 1, 4, 8, 7, 5, and this must be 6. If it's 5, 6, this becomes 7, 8, 4, 3, 1, and this is 2 or 9. If it's 6 and 7, this becomes 4, 8, 5, 3, 1, and this is 2 or 9. If it's 7 and 8, this is 5, 6, 3. Oh, can't be 7 and 8. Let's try that again. If it's 7 and 8, 7 and 8, this becomes 5. This is 6 and 3, but this is also 3, so it cannot be 7 and 8. It could be 6 and 7, though. Could be 6 and 7. If it's 8, 9, this is 2, 3, 6, 7, 5, and this could be 1 or 4. Really. Okay. Hmm. If 5 is bottom row, this is 7, this 5, this is 1. So if this is 5, 6, what does that mean? If this is 5, 6, this is 7, this is 8, 4, so this is 1. This is 4. So that seems to work. If this is 5, that means this is 5, which means this is 1. So that also seems to work, right? 2 and 6 would go with 5 and 4. You have a 9 and 1. This is consecutive, which means it's odd. These are odd, so this is a whole is even. So the other ones have to be even. We know this is a odd, a 1 and a even, so that's odd. We don't know about this. We don't know about this. Hmm. Mm, I guess we have to just try it out, right? Uh-huh. Okay, so if this is 5, this is 6, this is 9, this is 2, this is 1, this is 4. So then this becomes 3 and 6, which makes that 7, which makes this 5. So this would have to be 8 and 9, and that's 1. Okay. So that's if that's 5. So this is 8 and 9, and this has to be 8 and 9, and this would be 1. If that's not 5, that means this is 5. So this is 5, this is 4, this is 1. This has to be 2 and 6. Oh, wait. Yeah. This has to be 2 and 6, which makes this 9. So this is 1. This can't be 4. This can't be 5. So this is 1, which makes this 7, which makes this 5. So no 5. So the 2 has to be one of these, or it's this one, right? This has to be 2. So if it's either 2 and 3. If it's 2 and 3, this becomes 4, 8. And this would be 7, and this would be 6. So 2, 3, 8, 7, 6. 8, 4. This would be 7, 5, and that would be 6. So that's 2 and 3. Otherwise, this is 2. And it cannot be 3, 4. It cannot be 4, 5, because then this would be 7, this would be 3, and this would be nothing. Can it be 5, 6 then in this instance? So if this is 9, this is 2, 5, 6, 7, 8, 4, 3, 1. Yeah, that seems to be fine. So 5, 6 does work. 6, 7 makes this 5, this 3, this 4, 8. Yeah, so 6, 7 works. 7, 8 does not, and 8, 9 obviously does not because the 9 would be there. Oy. Uh-huh. Oh, this can't be 5 anymore here. Oh, it could be 5, and the 9 could be below it. Yeah. So this can no longer be 5. If this is 5, it does not have a 9 below it, obviously, and it doesn't have a 1 above it. So this can't be 5. This could be 5 because the 9 would be below it. This could be 5 because the 9 would be below it. This could be 5 because the 9 could be below it. Can this be 5? Yes, because the 1 could be above it. The 1 has to be with the 5 here. Oh, we already knew that. Hmm. Hmm. Let's see. Kind of stuck here, actually. Interesting. What does this consecutive stuff here mean? These are all, this combined is even, this is odd. So therefore this total is odd, which means these two plus these two must be odd. But we don't even know what this could be. This could be 9. So we need 5. So the 5 is with a 1. This could be 5. These could be 5 as long as the 9's below it. Um, hmm. So the 5 could be here, which means the 9 could be there then. Okay, so this is taken care of. 8 to 16, that's fine. 1 to 2. 4 to 8, 5 to 6, 22 to 11, 28 to 14, 11 to 12, 11 to 12. Interesting both times. 10 to 11, 11 to 12, another time. This is either 11 to 10 or it's 8 to 9. This has to be, this is 18 to 9. We have a 3 to, this is 5 to 10. This is consecutive. Huh. This is, we don't know. So that's consecutive. But right now, that we don't have any additional information up there. Hmm. Huh. Where are the ones? Where are the nines? I don't know. I'm not seeing it. Hmm. Mm. Oh, this can't be 3. So this can't be 2. Right, we already knew that before. 2, 3, 4, 8, 1, 9, 7, 5, and then this is 6. So that seems feasible. These are consecutive. That doesn't really tell us much, though. Oh, excuse me. 12 and 11. Yeah, so I went through both of these. They both seem to work. So this is 5, this is 6, this is 9, this is 2, this has to be 1, this is 4. That makes this 3 and 6, which makes this 7, which makes this 5, which makes... Oh, that doesn't work. Interesting. Okay. You just got to go through, I guess, all the possibilities. 9, 1, and this is 2, 4, which makes this 3 and 6. Which makes this 7, which makes that 5, which makes that 1, which is contradiction. So it cannot be 5 there. Therefore, it's a 2, 6 here, which means this is 5, this is 9. So this cannot be 8 and 9. Can't be 9 anymore. It can't be 7 and 8, because then this would be 3, 3. So 8 can't be here. This can't be 5, so this is 1, which makes this 5. So this can't be 5 anymore. So it's 6 and 7 or 2 and 3. This is 7. So this can't be 7 anymore. This can't be 1, so this is 4, right? And this is 1. So this can't be 1. This is 2 or 3, or 6 is 7. So if it's 2, 3, this is 4, 8. If it's 6, 7, this is 4, 8. So this has to be 4 and 8. These can't be 4. The 4 has to be here. This can't be 2, so this is 3, this is 2, this is 6. There is no 2, there is no 3, so it's 1, 4, 5. This must contain an 8 and a 9, and a 3 or a 7. This can't be 3, though, so we have that. 1 has to be one of these two. Okay, this is either 2, 3, or it's 6, 7. This is 3 or 7, so this is the opposite, 2 and 6. Hmm. Huh. This is tough, this part. I don't know how you disambiguate these. This obviously has to have a 1. This obviously has to have a 3. One of these two. Oh, 5 and 9. The 5 cannot have a 1 above it, so the 5 has to be with a 9 below it. Here. The 5 has to be with a 1 above it here, and the 5 could be any of these with a 9 below it. Okay, what does that mean? So say, so this 5 has a 1 above it. This 5 has a 9 below 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 it. This 5 must have a 1 above it. This 5 could have a 1 above it or 9 below it. This 5 has to have a 9 below it. Okay. Okay, so we know this is even. This is even. This is odd. So the whole thing is odd right now. The whole thing is odd. We need an odd. But this could be odd, which would force this to be even. So say this was odd. This is 3 and 2. That means this has to be even, so it cannot be 9. Therefore, this would have to be 9. This can't be 5, 9 anymore with the 5 below it, so this is 4. So this becomes 1 or 5. This can't be 9. This can't be 9. This can't be 2. This can't be 2. This can't be 4. We have a 6, 8, 6, 8 pair, so this is 5 then. This has to be 7. So no 7. This is not a 7. This is 3. This is 7. This is 6. This becomes 8 and 9. This can't be 3. These can't be 5. This has to be a 3. No 6. No 6. This all seems possible. Oh. Hmm. This seems all too plausible. Hmm. Yeah, I don't like this, but I don't know how else you can attack this. So say this was 6, which would mean this is 2. So this is all even. This is odd, so this must be odd. So this could not be 9. This would have to be 7. This would be 3. This would be 7. So obviously no 7 here. This cannot be 9 because the 9 would have to be here to make this odd because it's with an even. There's the same here. Yeah, I don't. This doesn't seem to go down any particular path that's great. No 6, no 6. Hmm. Okay, so this is in 8 to 16, 1 to 2, 4 to 8. 5 is consecutive with 6, 12 is consecutive with 11. 14 is in a 1 to 2 with 28. 22 is in a 1 to 2 with 11. 11 is consecutive with 12. 11 is consecutive with 12. 11 is consecutive with 12. 10 is consecutive with 11. 11 is consecutive with 12. 18 is in 2 to 1 with 9. 10 is in a 2 to 1 with 5. 9 is in consecutive with 8. 2 could be consecutive with 3. 6 could be consecutive with 7. Hmm. Okay, I'm gonna pause because I need to go bathroom, and this doesn't seem to be getting anywhere. Shoot, sorry, I forgot to. Let me go through my logic again. I forgot to unpause my video once I came back. Okay, so my logic here. Okay, so what I came up with. Okay, well, what I found was if I had a 4 here, this became a 1-5 pair, right? Now, the problem with this is that the 5 here in box 9 always has to have a 9 below it. It's because there's no 1 above it. So the 5 has to always have a 9 below it. So this can't be 9. So try putting one of the 5s here. If this is 5, then this becomes 9. This has to be 1. So this can no longer be 5, so it's 7, but this has to be 5, and it has to have the 1 above it, so you have a contradiction. And that happens either way if the 4 is there. So the 4 cannot be there, which means we know that the 5 is there. So the 5 has to be there, and then the 9 has to be below it, which forces this to be 7 because it's the only place where 7 can be now, and therefore this is 6, this is 2, this is 3, this is 7. So now we know this is 3 and 8, this is 1 and 4. This can't be 5 anymore. In addition, we know these are even. These all added up are even. So these are even, this is even. You have a 1 and an even number, so that's odd. Therefore, you have to have an odd number here, which is an even number and a 9, which would be odd. So this can't be 9, and this can't be 9. Okay, well, we already knew that can't be 9 because of this. So the 4 has to be here and then here. So therefore, there cannot be a 4 in the rest of column 8s or 9. So 4 has to be one of those two. And now we're just probably adding stuff up. So this can't be 2, this cannot be 2 or 6, so this is 3 or 5. One of these is 9. This can't be 2, this can't be 2. This has a difference of 5. This has a difference of 3, this has a difference of 2. Whew. Can this ever be 2 is the question. If this is 2, you would have to pair it with a 9. So let's try. Okay, so this can't be 6. This can't be 6. So we know the 6 is over. This can't be 6. This could be 6. So one of these 3 or one of these 4. Okay. So then let's try this as a 2. If this is 2, what could this be? This would have to be 9, which makes this 6. So this can't be 6 then. So it's 8 or 9. This can't be 6. It's a 1-8 pair. So this has to be 2. This has to, what did I do? This has to be 2. This is 4. This is 6. This is 4. So this becomes a 1-8 pair. If that's the case, then this is 6. This is 6, this is 8, which makes this 9. So that's a difference of 7. So, yeah, that's a lot to make up. I don't think you can have 3, 8 here. So this has to be 5 then. And that would be 3. So this is a difference of 7, and then a difference of 9. So this would be 5. Therefore, probably the higher number would always have to be here, right? But is that the case? 5, 1, 8. This would have to be 1, 4, so that works. This is 3, 8, so that works. What does this add up to? 3 plus 2 plus 4. 2 and 8 is 10. 4 and 3 is 7, so it's 17. 1 and 9, 18, so this works, actually. So it could be 2. Dang it. Yeah, maybe we have to put the 5s and the 9s. So say this was 5 and 9. So we tried, okay, so if this is 5 and 9, this is 7, this is 5. This has to be 6, which makes this 9. So this is 2 and 4, right? So then this follows the pattern. So then this becomes 6 and 8. This then becomes a 2. Okay, so that does work. And that's probably the solution. So then we go the other way. Let's have this be 5 and 9, right? Because the 5 now has to follow the 9. So then this has to be 7. This is 5. This has to be a 1. This is an 8. This is a 4. This is a 1. So this is a 2, which means 4 has to be here. This can't be 9 anymore. Where's the 9 here? It has to be here. So then this becomes 4. This is 7. This is 3. This can't be 3, so this is 8, 3. This is 6. So what do these add up to? This is 15. 1, 5, and 9. Plus 3 is 18. This is 10. This is 10 and 21. 11, so 21. So it's 18 and 21. So we know that one specifically doesn't work. I don't really like that, but I don't know how else you can attack this, really. 5, 9, 7, 4. This is 7, this is 5, so that's a 1. This is 6. This has to be the 9 then. This is 2, because it can't be anywhere else. This is 4. This is 6. This is 4. This is 6. This one means this is a 4. This is a 1. The 4 means this can't be 4. No 1 or 6, so this is 8, which makes this 3, 8. This is 6 and 8. So this is 2 and 6. This is 2 and 6. This has to be 2, and that's a 3. And that's a solution. So yeah, I'm not really sure how else you can really attack these, aside from just putting in numbers and basically seeing what happens. I'm not really liking this portion, but the other stuff was really fun. And this was clever. This 4 not being that possible, and therefore you know that this has to be odd. It's kind of clever. Yeah. Anyways, I hope you enjoyed the solve, and I'll see you next time on Frank Puzzles. Take care.